All right, number 16, we want to determine whether the following statements are true and give counterexample explanation. So A says if a constant function on an interval AB, um, then the right and left Riemann sums give the exact value. Is this true or false? So if we have a constant function, doesn't matter where it is, straight across, between A and B, let's just call this A and B, we're going to have a rectangle. All the heights will be the same, so it doesn't matter if we use the right or left Riemann sum. Both will give us the exact same value. So we're going to say true, area under the constant function is a rectangle, so Riemann sum cover exactly the same area wholly. All right. All right, part 2 says if a linear function on an interval AB, then the midpoint Riemann sum gives the exact value a, b, f of x for any n. Is this statement true? So when we deal with a linear function, okay, and it could be increasing or decreasing, let's just call it an increasing function. Let's say that this is A, and this is my point B. So we'll make some partitions, and with midpoint, for a linear function, we would go left and right. Now you will have part of the graph below and part above, and those are the exact same value every time we use the midpoint. The part below the graph and above will be equal. So it will balance out to give us the exact area when using the midpoint of a linear function. So it says true, it gives an approximation of the integral but never the exact value. And it says true Riemann sum or rectangles, the part that is beyond the function is equal to the area under the function and for the entire rectangle. So C is going to be the correct answer choice. All right, part 3 says, is the equation 0 to 2 pi over a sine ax dx is equal to integral 2 pi over a cosine ax dx, true or false? Are these two equal? We'll say yes when we do sine and cosine. Let's just say from 0 to 2 pi. Pi half, pi 3 over 2, 2 pi. Power 2, pi 3 pi over 2 and 2 pi. So whenever we do sine and cosine, let's just say that this is 1, this is negative 1. Sine starts at the origin and it goes up, comes down, goes down below to negative 1. That might not be in the right spot, but and then comes back up. So we get a part above, a part below, it evens out. With cosine, it starts up at a height of 1, but it does the same thing. So we'll have, it'll go down here, and then come down to 1 here. Then it goes back up, and then it comes up to this point. So this is half a circle, this is half, and so it gives you that whole shape. But they both end up having the same area. And that net area should be 0. These two combine to be that part below, and then this part above and that part below. So they both have the same area over 2 pi. And so I would say that this is true. They're the same. Says true integral covers one period. of the given trig function. Cosine graph is the same as a shifted sine, which you can kind of see that if you shift it over, which does not affect the net area. At the net area, both graphs are 0. All right, part 4 says if the integral from a to b of fx dx is equal to b to a of fx dx, then f is a constant function. I wouldn't say that it's a constant function if those are the same. The only number that stays the same when you add a negative to it would be 0, because from a to b of fx dx, that's the same as the negative when you flip the limits, b to a of fx dx. And the only thing that doesn't really have a sign is 0. So these both would have to be equal to 0 for that to work out. And so not necessarily constant, so like 5, 6, or any constant. This says false. Integral from a to b is equal to b to a. Then a to b is equal from b to a, which is equal to 0. That looks good. This says true, a to b equal here, which is equal to -1. That will be different because if one's -1, the other one will be +1. It says true, a to b is equal to b to a. F of x, then f of x equals 0. What is the difference? This one just says false. So it wouldn't be true for a constant. It would be true for 0. So the difference between those is the true or false. So if this is, then f is a constant function. And it says a constant. It could be any constant function. So I would say false. It has to be 0. All right. All right, part 5, last part, says the property integral from a to b, c times fx dx is equal to c times the integral a to b of fx dx for any constant c, implies that the equation integral a to b of x times fx dx is equal to x times the integral fx dx is true. Is the statement true or false? So x is a variable. Now c is a letter that we would call a variable, but it's representing a constant number. X is a number that's changing. It's not the same. And so this would not be true. So it says false. Property only allows a constant to be factored out, not a variable. And we would go with C. This one says false. And then it has separated it. And we haven't talked about a multiplication property. We've done addition and subtraction, but we haven't done a multiplication property of an integral.